All right, so this question here, this says the solution set to the inequality of negative 2x squared plus 8x minus 6 is greater than 0 is what? Show work. Okay. So what we want to do, I'm going to expand this out a little bit. So what we want to do is you want to, you don't have a graphing calculator for this one. This one you're going to have to do algebraically. So it's one variable, right? So what we're looking for are solutions for x that cause this statement to be true. So what are the values for x that make this side positive? Now you could just do test points, but that's going to take a long time and you might not guess right. So what we want to do is we want to factor. Now some of you in this question that I saw, which I think is a great idea, what you did was you divided or you multiplied, however you want to view it. Divide everything by -1 to make this a positive. Now, it's a little trickier to factor if it's negative, maybe. So I like it when it's positive, but if you do this, and this is where the mistake came for a lot of you that I saw, you change the signs here, which is great. So that's a positive 2x squared, that's a minus 8x, that's a plus 6. When you divide or multiply by a negative, what you have to remember to do is flip the inequality sign as well. So if you divided by or multiply by a -1 to get this trinomial here, and then you didn't flip the sign, that's a problem. Okay, that's problem number 1. Problem number 2 came here. Okay, see, now that you've done this, you kind of like almost forget about this one now. You cannot go back to this per se because you might get things mixed up. So now you're looking for negative values. That's important right there. You're looking for negative values now. So some of you did this and got this positive, okay, got this to be positive right here. But then you went back and remembered, hey, I'm looking for positive values. So no, you can't have it both ways. So you kind of got to forget about this now and focus on this. Another thing that's a good idea to do is you can divide both sides of this inequality by 2 here. That's a great idea to simplify this even further. When you divide or multiply by a positive number, you do not flip the inequality. So this is just x squared minus 4x plus 3 is less than 0. 0 divided by 2 is still 0. Okay, so this is a very manageable expression now, right? We can factor this, is what you're going to want to do. The long way would be using quadratic formula, finding the roots, and then test points in between those roots and stuff, right? That's the longer way. This is maybe the easier way, and I would suggest that using sign analysis might be a little bit quicker, okay? Which is probably what you want to do. So I would suggest sign analysis. I didn't require you to do sign analysis here, but that might be probably the way that you would pick. That or finding the roots and using test points. But I'll show you sign analysis because, again, some of you needed help with sign analysis, which we'll talk about later as well. So this is going to be what? X minus 3x minus 1, okay? When you factor this, so you want two numbers that multiply to positive 3 and add up to -4. And this is the arrangement here. So remember, this is still less than 0. Sign analysis. You use all of the factors, all of them. Here we have x minus 3 and x minus 1. Okay, so number line down at the bottom. Again, some of you didn't get this quite straight, okay? This is not 0 at -3. Some of you did that. This is not 0 at -3. This is 0 at positive 3, okay? Because positive 3 minus 3 gives you 0 here. See that? So you got to make sure you get that straight. Now, any x value that's less than 3 would cause this particular factor to be negative. That's why we put negative signs on the left of the 0. Any x value that's greater than 3, when you plug it into this factor, would give you a positive value for the factor. That's why we put plus signs over there. And here, similarly, at positive 1, we have a 0. Minus before that, it's positive after. What this is doing is now giving us we can easily determine the overall signs and where they are attached to the domain or the x values for this function. So the function here, which is just this right here, right, is positive here before 1. It's 0 at 1. It's negative in between 1 and 3. It's 0 at 3 and positive after 3. Therefore, I can take a look at these signs because this is the function right here that we were dealing with. So I'm looking for less than 0. Where is the negative region? It's between 1 and 3. You see that? Between 1 and 3. 1 and 3. It's in here. And it's not or equal to, so it's not including 1 and not including 3, just in between. Okay, so where is that? That is right here, between 1 and 3. That's this notation right here, but not including. So it's not this one, which a lot of you chose, because I think what happened was you went back to the beginning and you said, okay, I'm looking for greater than here, so where is it greater than? And you identified these regions as the solution. But when you change these signs, you have to kind of forget about this one and you have to focus on this now, right? Or this, or whatever, any of these. Okay? So that's the first thing I would caution you or correct you on is this one, because a lot of you chose B actually, and it's D here. So any questions about that one? Yep. Okay, thank you. I was going to address that in the next example, but I'm glad you brought that up now because this is valid as well. So what happens if you don't actually like divide out a negative 2? And what happens if you just factor it right like this? Well, then you don't change the sign. That is absolutely true. But, okay, when you factor this, okay, this obviously is going to be factored to x minus 3, x minus 1, right? But what you can't forget is that you do have a negative 2 as a factor as well. So if this was the case, if you did this, and this will come up in pre-cal 30 and calculus, and you'll have to, this is something we just haven't run into yet, you do have to put your negative 2 as a factor along with the other factors. Okay, why? Because it's negative is the big thing, because what happens is negative 2 is negative everywhere. It's always negative, isn't it? And that does change what we see here when we multiply. So when you multiply 3 negatives together, that's actually equaling a negative. When you multiply 2 negatives and a positive, that's a positive. And when you multiply a negative and 2 positives, that's negative. So if you don't change the sign and you just factor that 2 out, you have to put the 2 in here, and then you compare this, because you didn't actually change it, you just factored from there, and now you're looking for the positive, see, where it's positive, and that would still be the same solution set. It's in here. Okay? So you factored it, and you didn't change it, which was great, but I guess you didn't include the negative 2 as a factor, correct? Yeah. Okay, awesome. We know that now. That's if you have, now if this 2 was positive, look at, if this 2 was positive and you factored it out, well, guess what? A positive here doesn't change anything. So would you have to put it up there? I guess you wouldn't have to put it up there because it doesn't change the sign of the overall thing. But if it's negative, you definitely do have to include it, okay? So thanks for bringing that up. Okay, another question that was asked was about sign analysis. So some further work on sign analysis. Okay, what you want to do here is you want to factor a trinomial. If you're given a trinomial or an expression, factor it. So this is going to be x, what is this, plus 4 times x minus 3, okay, is greater than 0. Now, 4 times negative 3 is negative 12. 4 minus 3 is positive 1. So this is factored correctly. In this question, I remember some of you just did not factor this correctly. So if you factored it as like x plus 12 times x minus 1, sorry, that's incorrect. Everything else is going to be wrong. I will give you partial credit if you do the sign analysis correctly with an incorrect factorization, but you won't get full marks, right? You're going to get dinged on that. So you got to start off with the right factors. From now, all of these factors, there's only 2 of them there. So now using sign analysis, I put x plus 4 here and x minus 3 here. I know that I'm going to be able to determine the sign of my function down here, and this is a number line. I first want to put the x value on the number line that causes my first factor to be 0. That's going to be negative 4. Now, why did I put negative 4 here and not over here? Because I know that the other factor is positive 3. It's always a good idea, actually it's necessary, to make sure that on this bottom number line that you have your numbers in the correct order. So you can't put positive 3 over here. Does that make sense? This is not going to work if the number line is backwards. So I've never really mentioned that, but of course positive 3 should be on to the right of negative 4, so the number line is accurate. Okay, so when we do that, I put a 0 here in line with this factor because negative 4 as an x value yields 0 for this factor. Any x value that's less than negative 4, like negative a billion plus 4 is going to be a negative number, right? So you put negatives here. any x value that's greater than -4, greater than, like 3, 3 plus 4 is +7, so these are all positive values here. You do the same process for the second factor, and if there are 3, 4, 5 factors, you just keep doing the same process. Make 3, 4, 5 rows, and then you'll be multiplying all those signs together to get your final one for each section. So this is a 0 here, and it's negative ahead of time, and it's positive after. Question I have too, is this always negative to the left of 0 and always positive? If the x value here in these factors, if the x value is positive, then yes, it's always like that. If you had a negative x minus 3 for some reason, then it would be opposite. Okay? No, not necessarily foreshadowing. Could you run across that at some point in your future math career? Absolutely, you will. Yes. So in a sense, it's foreshadowing, but it might not be immediate foreshadowing. Okay? Did you have a question? That was what it was? Yeah. I have my spidey sense tingling there. As soon as your hand went up, I'm like, I know what he's going to ask.
I was going to ask when it's like only 2 factors like that.
Well, no. Yeah. Is it always negative in between when you have 2 factors like this? Well, if you have 2 factors like this and both x values are positive, then yeah, it'll be negative in between. But that's a shortcut that you don't really want to focus on at all because you're going to get yourself messed up. Okay, so make sure you just follow the process. But yeah, that's a pattern that you'll see often, yes. Okay, so negative times negative is positive. This is 0. This is negative. This is 0. This is positive. All right. So again, we didn't change the sign. I'm looking at a positive, right? Where are the positive values? So the solution set here is going to be this region that is less than -4. So x less than -4, and it's not or equal to because there's no little or equal to signs here, right? Those don't exist, so I don't put them here in my solution. X is less than -4, and x is greater than 3. Now, the proper convention is to write it like this, okay? Now, I did see some of you, and I made a little note on your quizzes, but I did see some of you write a solution set like this. You did x greater than -4, less than -4, greater than 3, okay? This is not the convention to write the signs in this fashion as greater thans, okay? So we will not be using this, even though technically in its reading from x, this is correct. This is not the convention that we will write this. So we will separate this like this, okay? If it's a one continuous section in the middle, then you can use the set notation that involves the less thans or less thans are equal to. That's okay for the middle section. But when you have 2 separate sections, you're not going to write it as one thing, okay? So we're going to stay away from this. On your quizzes, I did not mark you incorrect, but I did make a note. Please don't write it like that again. It would be like, it would be like me saying, okay, from now on, I'm just going to write my last name backwards, and you just all have to deal with it. That is not the convention, okay? My name is not Mr. Luxam, okay? My name is Mr. Maxwell. So it's the same sort of thing. There's just conventions so that everybody is on the same page, no one is confused. And that came up too. Okay, any other questions about the quiz or about anything to do with 9192?
Didn't mark them wrong?
I did not mark them wrong. Yeah.